Hello student. Today's topic is large sample theory. Now what is the large sample theory? Before giving the notation of sampling, we will first define population. In a statistical investigation, the interest usually lies in the assessment of the general magnitude and the study of variation with respect to one or more characteristic relating to individual belonging to a group. This group of individual under study is called population or universe. Thus, in statistics, population is an aggregate of objective, animate or inanimate under study. The population may be finite or infinite. Now, it is obvious that for any statistical investigation, complete enumeration of the population is rather impracticable. For example, if we want to have an idea of the average per capita, which is monthly income of the people in India, we will have to enumerate all the earning individuals in the country, which is rather a very difficult task. Now, let me tell about what is sample and what is sample size. Okay, now what is sample? A finite subset of statistical individual in a population is called sample. I repeat, a finite subset of statistical individuals in a population is called sample, and the number of individual in a sample is called the sample size. So, what is sample size? That the number of individual in a sample is called sample size. Okay, now we are knowing about types of sampling. The first one is purposive sampling. Okay, it's purposive sampling. Purposive sampling is one in which the sample units are selected with definite purpose in view. For example, if we want to give the picture that the standard living has increased in the city of such like New Delhi, we may take individual in the sample from rich and post localities like Defense Colony, South Extension, Golf Links, Greater Kailas, etc. etc. and ignore the localities where low income group and the middle class families live. The sampling suffers from the drawback of favoritism and nepotism and does not give any representative sample of population. Okay, and the second one is random sampling. It's random sampling. Now, what is the random sampling? In this case, the sample units are selected at random and the drawback of the purposive sampling, favoritism or subjective element is completely overcome. A random sample is one in which each unit of population has an equal chance of being included in it. Okay, now we have the third sampling and its name simple sampling. Simple sampling is random sampling in which each unit of population has an equal chance. You may say P of being included in the sample, and that is probability is independent of the previous drawing. Thus, a simple sample of size n from a population may be identified with series of n independent trials with constant probability P of success for each trial. And here the fourth one, and which is the last one of sampling, it's certified sampling. So here the entire heterogeneous population is divided into a number of homogeneous groups, usually termed as strata, which differ from one another, but each of these groups is homogeneous within itself. Then units are sampled at random from each of these stratum. The sample size in each stratum varies according to the relative importance of the stratum in population. The sample, which is aggregate of the sample unit of each of stratum, is termed as certified sample, and the technique of drawing this sample is known as stratified sampling. Such a sample is by far the best and can safely be considered as representative of the population from which it has been drawn. Now, what is parameter and statistics? Here the next part, parameter and statistics. In order to avoid verbal confusion with the statistical constraints of the population, mean you may know mean is mu, variance sigma square, etc., which are usually referred to as parameters. Statistical measure computed from the sample observation along mean x bar, variance a square, etc. have been termed by Professor R.A. Fisher as statistic. Now here is a short note. Now onwards, mu and sigma square will refer to the population mean and variance respectively, while the sample mean variance will be denoted by x bar and a square respectively. For unbiased estimate, a static t, small t equal to small t x1, x2 xn, a function of sample values x1, x2 xn is an unbiased estimate of population parameter theta. Now if Et equals to theta, in other words, if E statistic equal to parameter, okay, then statistic is said to be an unbiased estimate of the parameter. Now the next topic is standard error. Now what is standard error? The standard deviation of the sampling distribution of a statistic is known as its standard error. The standard errors of some of the well-known statistics for large sample are given below, where n is the sample size, lambda sigma square are the population variance, and p the population promotion, and q equal to 1 minus p. N1 and N2 represent the size of the two independent random sample respectively. Now we draw the chart and put it here the serial number. It's very important. It's statistic and this is standard error. It's so much important. Please note it down and put the serial number 1. At first we write sample mean, which is x bar, and the standard error of sampling mean is sigma by root over n. Okay, the second one, observed sample proportion, it's small p, and the standard error pq by small n. Third one, sample st, it's small s, and the standard error root over sigma square by 2n. Fourth one, sample variance, which is small a square, standard error sigma square root over 2 by n. fifth one is sample quartiles. Standard error equal to 1.36263 sigma by root over n. Okay, let's draw the chart. Okay, now we are going for the sixth one. It's sample median, and the standard error equal to 1.25331 sigma by root over n. The seventh part equal to sample correlation coefficient, it's small r. Sample error equal to 1 by rho square by root over n, and here rho being the population of correlation coefficient. Okay, now going to the 8, sample moment. It's mu 3. Standard error equal to sigma cube root over 96 by n. Number 9, sample moment once again, but it mu 4, and here the standard error mu to the power 4, sorry, sigma to the power 4, 96 by n. And number 10, sample coefficient of variation, which is small v. Standard error equal to small v root over 2n root over 1 plus 2v cube 10 to the power 4 v by root over 2n. Okay, now going for number 11, difference of two sample means x1 minus x2. Put the bar on the top of this. Standard error equal to sigma 1 square by n1 plus sigma 2 square by n2. There are also two things. It's number 12, difference to sample ST notation S1 minus S2, and the standard error equals to root over sigma 1 square by 2n1 plus sigma 2 square by 2n2. And the last one, number 13, difference to sample proportion P1 minus P2, and the standard error P1 capital Q1 by N1 plus P2 capital Q2 by N2. Now we are discussing about the utility of standard error. Now what is the utility of standard error? It has a very important role in large sample theory and forms the basis of the testing of hypothesis. If T is any static, then for the large sample, capital Z equal to T minus E T by root over capital Vt. It's N0 1. That imply we can write Z equal to T minus Et is E T in 0 1 for large samples. Okay, so